Hello everyone, today we will learn two key programming concepts, enumeration and state machines. These concepts will help us make our Arduino programs more concise, readable, and improve the maintainability of the code. In programming, if we directly use numbers to represent different states, for example, 0 for off and 1 for on, the program may run correctly. But it is hard for people to immediately understand what each number means, which can easily lead to mistakes. The purpose of an enumeration is to give a set of related integer values meaningful names, thereby improving code readability. Here's a simple example. In this code, off corresponds to the integer 0. On corresponds to the integer 1. This way, when we write current state equals off, in the program, it is immediately clear that the light is off, rather than having to guess what current state equals 1 means. In fact, many common terms we use in Arduino, such as input, output, low, and high, are also defined in a similar way using enumerations, although these details are hidden in the underlying system. A state can be simply understood as the mode or behavior a system is in at a particular moment. Just like matter can exist in solid, liquid, or gas states, electronic devices can also have various states, such as on, off, waiting, alarm, and so on. In Arduino programming, because the program runs in a continuous loop, we need to determine the current state to control different behaviors. A common approach is to use a state machine. A state machine is a programming pattern that defines a series of states and the transitions between them, helping us organize code in a clear and maintainable way. On Arduino, there are two common methods to implement a state machine. If-else chain judgment is suitable when the number of states is small. For example, in this code, it first checks if the state is equal to 0. If so, it will execute the operation corresponding to state 0. If the state is not equal to 0, the program then checks if it is equal to 1. If so, it will execute the operation corresponding to state 0. If the state is neither 0 nor 1, the program will execute the default operation. This structure is simple and easy to understand when the number of states is small. But as the number of states increases, the code becomes longer and harder to maintain. Especially when more states need to be added, the if-else statements can become cumbersome. The switch case structure is another commonly used method, and it is suitable when there are multiple distinct values. In this code, the switch statement checks the value of state and jumps to the corresponding case based on its value. This structure is particularly useful for handling multiple states because it is more concise and easier to expand than if-else. Each case corresponds to a specific operation, and as the number of states increases, the switch case structure keeps the code clean and readable while avoiding long chains of if-else statements. This approach becomes even better and clearer when combined with enumerations. Enumeration values start from 0 by default, but you can also manually assign values. Today, we learned the basics of enumeration and state machine programming, mastering how to improve code readability through enumeration and how to manage different program states using a state machine. In the next lesson, we will dive into line following control, exploring how to use a light-dependent resistor to enable the car to automatically sense and follow a line.